Alright guys, we are starting a new packet today, Unit 3B, also known as Section 3.4. This section has what we call rational and radical equations, but we're not going to do radical equations for another day or two. So today we're just going to focus what we call rational equations. You can see some examples here. Rational equations are equations containing rational expressions, meaning a lot of times they're labeled when you have fractions, multiple fractions. So to solve them, it can be a little tricky. To solve, we need to multiply both sides of the equation by the lowest common denominator, and that's to clear away the fractions. So that's always going to be our first step to get rid of those fractions. The next part, it says check for extraneous solutions by substituting into the original equation. What that is sometimes at first glance, it may seem like our solutions are okay, but sometimes when we test them out, they don't always work out all the time. And extraneous solutions are ones that don't work out when we go back and check. So in example 1 here, we want to solve and check algebraically. So we are going to take a look at the fractions here. We have denominators of 3 and 2, and we want to get rid of those fractions. So we have to think, what is the lowest common denominator of 3 and 2? Well, what you can do is a simple shortcut is imagine 3 times 2, and you can call your lowest common denominator 6. So in other words, 3 and 2, the smallest number that they both multiply into is 6. So, as the direction said above, we're going to multiply each thing by 6. So the first fraction will multiply by 6. The second fraction will multiply by 6. And even the 7 is going to multiply by 6. And you will notice how it will cancel out the fractions in a second. Now, the first one, we don't have to multiply by 6. What you're going to do is divide first. So 6 divided by 3 is 2. So what we're really going to do here, we no longer have the first fraction being there. We're going to distribute a 2. So 2 times x, and then 2 times plus 4. 2 times 4. Okay, now let's focus on the second one. 6 divided by 2 is 3. So the 2's gone. This is a 3. That's going to distribute with x times x plus 3. So 3 times x, then 3 times 3. Then on the right side, don't forget 7 times 6, 42. Okay, so now all of the fractions are gone. This now has turned into an equation that you guys have been solving for years now. We're going to solve for x. So on the left side, we can combine like terms. 2x plus 3x is 5x. And also 8 plus 9 will get plus 17. And then, now we're going to work on getting x by itself. So we're going to subtract 17 from both sides. And then divide by 5, and you'll have x is 5. All right, so let's go back and check, since that's what directions say. So we're going to go back into the original problem and plug in 5 for the x's. So the first one will be 9 divided by 3 is 3. Second one, plus 8 divided by 2 is 4. And then we know 3 plus 4 is 7. So that checks out to be okay. So that means we are satisfied. We know without a doubt that x is 5. Okay, let's try another one. Now, this one gets a little trickier. This one introduces an x in the denominator. So if you look at your denominators, you have 3 and 3x. So 3 and 3 will obviously be 3 for an LCD. And since there's an x on the right one, you must include it in your LCD as well. So what we're going to do is we're now going to multiply everything by 3x. So your first one, 3 divided by 3 can cancel, and then you're left with x times x is x squared. Your second one, just multiply 2 times 3, have plus 6x. And then your last one, 3 divided by 3 cancels. X divided by x cancels. So all you're left with is negative 5. All right, now what to do from there? There are a number of ways you can solve this. By the way, this is a quadratic equation. It has an exponent of 2. So that means we can get up to 2 answers. So you can either try to factor, or you can maybe try the quadratic formula, is one that I also suggest. I'm going to set this equal to 0 and try to factor. I'm going to add 5 to bring it to the left side. So then I go, okay, I can factor this. Not everything can be factorable, though. If it can't be factored, go to quadratic formula. If it can be factored, well, factor. So the x squared is x and x. Your signs are simple. Plus, plus. 2 numbers that multiply to get 5 and add up to 6. Those numbers are 1 and 5. All right, so now it's completely factored. Now I can go ahead and get what my possible answers are. So you set each factor equal to 0, and you simply solve. The first one, negative 1. The second one, subtract 5 to get negative 5. Now, before we move on, we are going to check for extraneous solutions here. So we're going to start checking the negative 1. Okay, so negative 1/3 plus 2. Now, 2 is the same thing as 6/3, so that would give me 5/3. Let's see if the right side gets 5/3. That would be negative 5 divided by negative 3. The double negatives cancel out, and you'll also have 5/3. So that means negative 1 is a solution. Now let's go check negative 5. Okay, so on the left side, 2 changes to 6/3. Negative 5/3 plus 6/3 is 1/3. And then this would be negative 5 divided by negative 15. The negatives cancel, and 5/15 is also 1/3. So negative 5 also checks out. So we do have 2 answers to this problem. Okay, let's try another one. Example 3. Again, we have fractions. The LCD in this problem is actually x minus 3. If they're both x minus 3, your LCD is x minus 3. So we're going to multiply both fractions by x minus 3. Now, remember, you want to be dividing first to see what you could cancel. Now, you actually get a lot of help here. This problem is, at first glance, this problem is very intimidating, but it actually works out to be super easy. X minus 3 divides with x minus 3, giving you just x squared on the left. Also on the right side, x minus 3 divides by x minus 3, leaving you with just 9 on the right side. Now we're going to get two answers here. Remember, we can just simply square root both sides. But remember, when you do that, to get rid of the exponent of 2, you got to throw in a plus minus. And then the square root of 9 is 3. So your two possible answers are 3 and negative 3. Now let's do our checks. Maybe one of them doesn't work out. Maybe both don't work out. So I'll check 3 first. Now, check out what happens. My denominators, 3 squared is 9, but the denominator is 0. Same thing on the right. Denominator's 0. So that turns out where this is not okay. So negative 3 would not, or sorry, positive 3 would not be okay. It's undefined here. So we refer to that as an extraneous solution. Now let's check negative 3. On the left, it would be 9 over negative 6. On the right, same thing, 9 over negative 6. So negative 3 does work out, and it's one of my answers. Okay, let's try another problem here. A little more difficult again. So we have x plus 5 and x plus 1 as my denominators. So this gets a little tricky here. We're actually going to have my LCD being two binomials. It's x plus 5 times x plus 1. So remember, you're going to take your LCD and you're going to multiply everything by your LCD. Be patient here. It's going to seem a little confusing, but it'll work out. So on the left side, remember, you divide to clear out the fraction first. So x plus 5 can cancel out with the x plus 5. So all you really have to do here is distribute x times 2x and then 1 times 2x. So x times 2x plus 1 times 2x. Now on the right side, here the x plus 1 can divide with x plus 1, so it's going to distribute the 6. 6 times x and 6 times 5. All right, so the fractions are gone. Now we can solve this. Let's set this equal to 0. We're going to subtract 6x and also subtract 30. 2x minus 6x will be minus 4x. Okay, to solve this, I don't like that 2 out in front, And I do also notice my other numbers are 4 and 30, which also divide by 2. So I'm allowed to divide everything by 2 to get rid of this 2 in front. And now I'm going to try to factor, or quadratic formula, whatever you prefer, but I know this can be factored. I see that my x is going to split up, x squared splits up x and x. I have a minus 15 for my c term, so when the c is a minus, that's plus minus. And two numbers that multiply to get negative 15 and subtract to get negative 2 with different signs. They would be positive 3 and negative 5. So now I'm going to go ahead and I'm going to get my answers. I set each factor equal to 0, and then I can simply subtract 3 and the other one add 5. And I'm going to check my solutions. All right, so let's check negative 3 back with the original problem. So it'll be negative 6 divided by 2 is negative 3. And 6 divided by negative 2 is also negative 3. So negative 3 works out. I'm happy with that as an actual solution. Now I'm going to check 5. So the first one, that'll be 10 over 10 is 1, and 6 over 6 is also 1. So 5 is also a solution. All right, so that's pretty much the gist of it. Example 5 is, if you look at this one, we're going to hit this up in a second part of the video, because when we hit problems like that, these guys will have to be factored before we do the LCD thing. So moving down, going to help you out with a couple more. Go down to rational assignment A. So my LCD in number 1 is, again, what on the page where it says rational assignment A. The LCD, I got denominators of 4, 5, and t. So the denominators of 4 and 5 is 20. Think 4 times 5, it's pretty simple. And then make sure that t goes with it. A lot of people don't realize this t, when you have a variable, it has to be included in your LCD. So now we're going to multiply everything by 20t. Okay, so the first one, let's try to get rid of that fraction first. 20 divided by 4 is 5. So it's 5 times t times 1 is 5t. Now the second one, 20 divided by 5 is 4. So it's 1 times 4t is 4t. And then on the right, t divided by t cancels out, and 1 times 20 is 20. And now we can solve this. There's no exponent, so no factoring, it's just getting t by itself. But first we're going to combine like terms. 5t plus 4t is 9t. And then divide both sides by 9. And that'll be 9 goes into 18 twice with a remainder of 2. So 2 and 2/9. Okay, guys, I'm about the 20-minute mark, so I'm going to stop there. Um, just hit up what I have for the assignment, and you guys should be good, and just ask questions later on if you have any.